Okay, so we're going to go ahead and look at the expectations for paper one, principles of product design and principles of design engineering. As the name basically describes, they're testing you on the basic principles of this course. So we are looking at materials, manufacturing processes, user-centered design, ergonomics, anthropometrics, all the basic principles of the things that we've covered during the course. And a lot of this is a rollover from the basic knowledge from GCSE and just a little bit more advanced. So let's go ahead and look at the types of questions and the basic layout of what we would expect to come up in this kind of paper. So here's a classic example. This one here, this is a battery packaging which is made from cardboard and thermosoftening polymer. So we've got a little picture here showing you where the cardboard is, where the thermosoftening polymer is, the battery casing, we can see the batteries inside. Now, a lot of times when they give you a picture, they're giving you a lot of information in the picture as well. So we're looking at this picture here, we can take a lot of information there and help us actually answer the question. So obviously the first part there, identify a suitable thermo-softening polymer for the battery casing. Now at this point here, we can see it's a clear plastic. We've got the idea that it's been molded around the shape, probably vacuum formed. Very simple process. We're looking at something like a polyethylene, a low density polyethylene, polypropylene, something similar, very simple to vacuum form, very thin and easy. So any one of those examples will just give you 1 mark. Okay. Now, we always need to remember what we are doing with these questions. Bottom right here, we've got this part here where we've got how many marks it is. That's 5 marks. It's already told us identify a thermoplastic and then explain 2 reasons why this thermo-softening polymer is suitable. So 2 explanations, which means point and explanation, point and explanation. That's our 5 marks. So first of all, we identify the polymer, and there's a couple of answers we can give here as always. Just name it, 1 mark, one and done. Now, when these next parts here, we need to always make sure that we give a clear point for the 1 mark and then a clear explanation for the second mark. We do that twice for the full 4 marks, and then we get 5 in total. So first thing, as I said here, let's look at our picture. It is a clear, transparent plastic. So it's obviously available as it's available in a transparent form. Some way of saying that is simple enough for 1 mark, and then an explanation. What is the reason we need our plastic to be transparent? So, as the case here contains the content, the customer can see the content inside. Now, when we think about batteries, batteries do degrade over time. They can kind of get old and split open and start to kind of spill their liquids out. We want to see that the product inside is good, clean, and new. So that's a great example there. One example for the fact that it's a transparent material, or it's available as a transparent material, so you can see the product desired, so the customer has that peace of mind to know that it's of good quality, it's not old, it's not degraded. Nice and simple. 1 mark for point, 1 mark for the explanation. A second one as well, again, as I mentioned before, there's a chance that the batteries could degrade and liquids and acids could spill out. So it's going to obviously need to be resistant to corrosion or chemical resistant. Some form of saying something like chemical resistant or resistant to corrosion is enough for that first point. And then an explanation. So should the batteries start to decompose, should they leak acid or any bits like that sort of thing, it would keep it safe away from the customer. It's not going to harm them, or it's not going to damage anything around it. 1 mark and 1 mark done. So there we've got a simple 5 marker. That's how we would go. Now, with a lot of these questions, they like to continue and they would like to move on from where it was there. So we started off with a nice simple battery question, looking at basic materials, as we said before, principles of the course. So we've got a basic material identification question, and then 2 simple explanations as to why it is suitable. We've always got to look at the question. So obviously our command question, explain, which means we know we've got a statement and then an explanation. Suitability is what the question is about. So that's the subject of the question. We need to make sure that we're hitting that points as well. And the first bit, just naming a polymer is fine. There are other things you could give as well. As always, they'll give you multiple answers you could give. You could talk about it being low density. You could talk about it being lightweight. You could talk about having good impact resistance. There's other ways of getting full marks. The nice thing about these courses, and as you can see with all these questions, there's always multiple answers you could give. I generally find there's always 3 or 4 obvious answers if it asks for 2. So here it continues. This is a bit of an evolution from our materials. We have our basic materials, woods, metals, and plastics. Then we go a little bit more into smart materials here. So this is where it's starting to go into a little bit more of the advanced stuff here. It's got a picture of a battery there, talking about how the battery checks. You can obviously press both sides. Now this comes into, if you remember when we were going through the PowerPoints, that material that you would put across a baby's forehead to check temperatures and bits like that. We're going to go for some form of a thermochromic material, thermochromic vinyl, thermochromic plastics, thermochromic film, thermochromic paints, any one of those. I would have just assumed this would be a thermochromic film going across that. Now, again, as you press at both areas and the current flows through, it produces heat, and that's where we obviously get the little bar that lights up with the different colors. Well, say it lights up, it glows with the different colors. Obviously, the more electricity is running through it, the hotter it gets, and the more colors that are shown as it goes along, similar to the thermometer on the baby's head. So just one mark for some form of thermochromics. Remember the words that we're looking at: thermo, heat; photochromic, light. All those things that we looked at before. So this one is going to be reacting to heat, the current flowing through it to go there. So um, again, another simple identifier, a smart material. Now we get down to this part here. They love to throw a couple of maths questions in there. Remember, about 20% of the paper is going to be made up of maths questions. Now, the nice thing about these maths questions is that they're practical maths questions that you will actually use in everyday life. And this is a simple little probability one. Calculate the probability of someone taking two fully charged batteries from the drawer. Show you working. It's 3 marks, nice and simple. So we're going to break this down one step at a time. First thing you need to do, okay, calculate the total number of batteries. That is painfully simple. We've literally got 15 fully charged batteries, 6 discharged. They are giving you a point for literally doing 15 plus 6 equals 21. It couldn't be simpler maths. That is 1 mark that they've given away to you. Okay. Now the next one, we need to work out, calculate the probability of both. So think about it once. The first time you reach into the drawer and grab a battery, what's the probability that it's a fully charged battery? So obviously the drawer will contain 21 batteries there, and you've got 15 out of 21 chances to get a fully charged battery. The second time you go into that drawer to get the second battery, you're now down to 20. This is where most people do trip up because they forget about obviously taking that number away and they just go for 21 again. But again, 14 out of 20 this time is your second probability. So you get 1 mark for identifying both of those probabilities. Quite simply, the third mark is just putting them into simple equation and working it out. So you got 15 over 21, which will give you 0.7142. You know what? You've got a calculator. You can go through the rest of it, but you can punch that into a calculator. 14 over 20 gives you 0.7 as a round number. Nice. 0.7142, so on and so forth, times 0.7 is going to basically give you 0.5. You can put 0.5, you can put 50%, you can put a number of different things. Your probability is 50%. Quite simply, the nice thing about these exams as well is that if your answer is correct, that's it. Full 3 marks, no arguments. Always do, like I've done here, show your working nice and clearly, because as you're going through, when you're showing your working, if you've made a simple mistake, and it could be a very simple error of you writing the wrong number by accident, they do carry the error forward. So it's possible to get nearly 1 mark off of 4 marks just by showing all your working. If you've done all the working correctly and you've accidentally put a number wrong, you could have still got 2 out of 3 marks on this one. So the question normally continues. This is normally where it starts to round off at the end. So we've gone through materials, we've done a bit of maths in there, we've done a bit of smart materials. We're going to finish off by going through some basic health and safety. Again, they love health and safety in these exams. You're going to get health and safety questions. This is a great one. Talk about risk assessments. Quite simply, identify and explain one reason why a workshop environment needs to have a risk assessment. So again, look at how many marks. It's 2 marks. Identify and explain. So you got to identify a reason and then explain why it's in there. It's 2 marks. Quite simply, you could say to help prevent accidents. That's an obvious identification. And then explain it, creating a safer work environment. Really simple. 1 mark, 1 mark. As I said before, there's so many answers you could give for this, though. You could talk about to identify potential risks similar to accidents, to avoid possible injuries or even death. That's a bit extreme, but you got the idea there. Legal requirement. It is literally a legal requirement to produce risk assessments in the working place, in everywhere, even in school where we are now. I have to go through and present so many risk assessments for the work that you do in the workshop when you are in school. It is ridiculous, but it is a legal requirement. So it's a legal requirement, so adhering to the law and avoiding potential lawsuits. That's an important one as well. Help with storage of hazardous materials. As you remember from when we're in school, we've got the chemical cupboards, we've got the cupboards where certain tools are locked away. They're all for safety reasons, to protect employees from harm, to protect property from damage. Again, this is, we've got four different examples we could have given here. So two marker. Any one of those with its explanation will get you 2 marks. You're done. You obviously would not need to do all of that. Any one of those would have been 4 marks for it. Next part here, complete a table to identify 2 hazards and 2 control measures for the workshop environment when using and storing batteries. So identify a hazard and a control measured. Hazard, right? If acid from a damaged battery comes into contact with the skin, it could cause irritations. Now think about when we look at lots of our chemical labels, there's the hazardous or the may cause irritation and bits like that sort of thing. So yes, acid is not great for your skin, so it can cause irritation. So a simple control measure is ensure the designated battery storage area stored in cool, dry place. It's in a safe place. You could have spoke about some various other things, but a simple hazard with the control measure is enough. 1 mark, 1 mark, done. Now it's a 4 marker, so we need to do 2 there. You could talk about old or flat batteries may leak out acid. Obviously, if it's a non-rechargeable battery, if it's just an old battery, that is depleted and it's done. Quite simply, you need to throw it away. Now, do remember batteries cannot go into standard bins. They have to be disposed of in special bins. So have a special bin for the correct disposal of batteries, some kind of reference to that sort of thing. But old batteries that may start to leak out acid, dispose of them. Quite simply, simple control measure, simple hazard. Now, as I've always said before, there are so many answers you can give for this one. Let's look at another one. Talk about them not being stored properly. A common mistake is people just throw batteries into a drawer um, all over the place. And the problem is if they touch end to end, they can obviously conduct electricity that's going through. It can start to build up and heat, and it can cause electrical fires and small fires and all sorts of different problems. So obviously regularly inspecting visual checks, maybe having safer kind of layouts of places where they can go. But any one of those control measures would pretty much fit with any one of those hazards. Again, I could go on forever, but we're not going to. You get the simple idea. Point, point, exclamation. It's a 4 marker. It could be done. And this is a simple example of how you would have a question that will go for a part A, part B, part C, part D. And as you can see here, this is a classic example of something that started with some basic understanding of materials. When it's something a little bit more advanced, maybe just some smart materials, a little maths question thrown in there as well, and finishing off a bit of health and safety risk assessments. This is a typical layout of a question of a 2-3-parter, and this is the kind of thing you'd expect to see in there. Some other examples. Here's another great example. They'll love you to name a material. So they'll give you a picture of something like this. Name a suitable hardwood for the step stool. Now, you can look at the pictures very clearly. We can see there's grain on it. We can see obviously what it's going to be used for. It even notes that it's a hardwood here. So we're just looking at hardwoods here. A whole load of them we could use: beech, maple, oak, birch, teak. Anything where personally, anything where people are going to be interacting with it. You can see here it's a step stool. People are going to be picking that up, moving it around. You can just about see in the picture there's a little hand hold in there. Someone's putting the hand in it. I always go for beech. Beech is one of our best ones because obviously it doesn't splinter. You don't want people getting splinters in their hand. It's a nice, safe reason as well, sort of thing. But again, any one of those would have been fine. State 2 properties of the material you've identified in part A that make it suitable for the step stool. As always, I'd always go for a beach example here. So we can go through, we'll go through this in a little bit more detail. And we spoke about this before, but remember, toughness, strength, and hardness are 3 different things, commonly mixed up amongst themselves. So make sure you understand the differences. This particular one here, we could say tough. That is an acceptable point there. So 1 mark for quite simply saying it is tough. Then you need to give an explanation. So it says obviously state two properties. So the property we've identified is toughness. Therefore, is likely to withstand heavy use, being moved and kicked around and walked on. People are going to be stepping on this. So obviously it's going to need to be tough. Simple explanation for that one, 1 mark and 1 mark. Remember, state two properties. Justify each answer. That's only 2 marks there. We need to give another one. We talk about obviously the close grain, therefore it's able to have a smooth finish and it won't give out split, won't give you splinters. Again, that's really important. We don't want wood to be giving people splinters, especially if they're going to be picking it up and moving it around. It's another safety consideration we could talk about from bits before. And again, there's so many answers we could have given this. We could have, as I mentioned before, toughness as well. You could have also spoke about strength. You could have spoke about a number of different things here. Oh, your aesthetics. Here we go. Could have spoke about aesthetics, so it won't need to have paint applied to it. Makes it more desirable. When we talk about obviously hardwoods have a nice look and finish to them. So it's not like an MDF, something like that we need to paint. It's got a good attractive finish to it. Durable, so it's longer lasting. So many different things you can give for this one. Let's move on. So we've got another example here. This is a belay device, the rock climbing thing. I don't know what this is, but we've got a picture of it there. We have a general idea of what it's supposed to do. Identify and explain two reasons why an aluminium alloy would be used. So now we're looking at alloys here, a little bit more advanced than our basic, obviously ferrous and non-ferrous metals, but we've got the aluminium alloy and we've got a basic understanding of what it's going to do. Identify and explain two reasons why this aluminium alloy would be used. So we look at the device, we have a general understanding of what it's, if you've never rock climbed before, you might be able to kind of look at the device and kind of recognize it. So we can go through obviously an aluminium alloys are tough, meaning they can withstand impact. Okay, now looking at the device, if someone's climbing, they suddenly slip and they fall, it's going to have a sudden jolt to it. That impact is obviously something that the stress and strain is going to be under. We need to know that it's going to be able to withstand that. So obviously, if that's what is in there, we can say it's tough, can withstand impact. There you go, 1 mark, 1 mark. It's a 4 marker. Let's look at the bottom there. So we only need to do another one of these. Quite simply, it's lightweight, meaning that there is less weight to carry when climbing. That's obviously a very important thing. If you're rock climbing, you don't want to be carrying lots of weight. Nice and simple, 4 marks. So many other things we could talk about this one. We could talk about strength on this one as well. Good strength properties, so they can withstand a lot of force. We could talk about, oh, of course, it's an aluminium alloy. Most of the Earth's crust is made up of this one. We talk about cheaper than other materials because it's so readily available. It is so cheap, so it's more cost effective. We can talk about the fact that aluminium alloy, remember, this comes from a non-ferrous metal, so obviously it's going to be corrosion resistant. That's going to be an important thing if you're climbing, rocks and outside in the outdoors. There's going to be chances of obviously contact with moisture or even rain. So, it's not going to corrode in bad weather. It's not going to be weakened by that. You can talk about finishes applied to it. We can talk about anodizing it. We can talk about all sorts of different things. Makes it smoother, makes it stronger, makes the rope go through it smoother and everything. There's so many different things you can put it in. A point and an explanation. It's as simple as that. Just make sure you're very clear. Identify and explain two reasons. So identify and explain. Name your property, explain it clearly. As you can see here, I've got loads of room on the page. It didn't need more than a line. Okay, so there's no reason to kind of waffle on for ages. Got to be very clear and to the point. You can move on, use your time wisely. You've got lots of time in the exam, but don't run out of time because you're unnecessarily writing too much information. Get to the point, make it clear. That's the key here. Here we go. Another example here. So identify a suitable thermopolymer for the body of the iron. It's got a picture of an iron there, clearly labeled with a little arrow saying where the body is, where the metal plate is. They're clearly showing you they're talking about the body here. This is another little thing to help you so you don't accidentally start talking about the wrong part here. So we can see it's pointing to the plastic part there. There's a number of different plastics we could use here, but we can look at the component. That's obviously going to be something that's going to be injection molded. It's quite a complex component. Polypropylene, possibly an ABS plastic. There's a couple of others where they wouldn't really be suitable because it needs to be hard and rigid. If you look at it, we've got the handle there. We need to be able to lift the iron up and hold it by that part. It's not massively heavy, but enough weight on there that it needs to be rigid enough. So again, it says identify a suitable method of commercial manufacture for the body of the iron. As I mentioned before, we can just look at that and know that is injection molding. We're not going to be able to vacuum form that because of obviously complexity of the shape on the inside. Any other forming process, press forming is not going to work. Sand casting obviously is for metals. It's nowhere near what we need to do. The only kind of method here is going to have to be injection molding. So obviously identification and injection molding, reason being, as I mentioned before, it's an intricate shape, complex mold, something like that. You could have also said something like injection molding because of the fact that it's going to be mass produced or batch produced or something like that. The number of products, obviously, with injection molding, you injection mold in the mold, open the mold, pop the product out, close it again, start all over again. You can continually do that in the way that we're doing it. Again, it's a two marker. Either of those answers would have been perfectly fine. I would have just simply gone for the fact that it's a complex mold, it's an intricate shape, therefore injection molding is the only one that's appropriate for this. Then you're done. It's nice and simple. Again, we've got a lot of space on there on the lines. It doesn't need to be that much. They'll normally follow up with maybe a manufacturing method here. So we talked about batch production earlier. Here we go. This shows a sheet metal part which is manufactured in batches of 5,000. It looks like possibly like a piece on the back of a computer, maybe where they've got the power unit and the little fan that goes inside there. I'm not too sure exactly what this bracket's for, but it's clearly shows a sheet metal part that is obviously going to be produced in 5,000 batches of 5,000. So describe the industrial manufacturing process which would have been used to manufacture the sheet metal part. So let's break this down and think about this. Let's look at the part there. Obviously, that started off as a flat piece of metal. So there's going to be some form of cutting or stamping for the holes inside there for the vents. Another form of cutting or stamping as well for the getting the actual piece cut out of a big sheet of metal. There's going to be some form of bending around a jig or a former to get it into that shape. And then looking at it clearly, that has been powder coated or dip coated in some form of a finish on there to go through. So we've got 4 marks in there. Describe the manufacturing process. They're 4 steps. So the first one's going to be something about cutting out the slots in there when it's still a flat piece. Second part is after you've cut the slots out, cutting out the overall shape. We could talk about CNC laser cutters. We could talk about stamping machines, hydraulic press or punch. Any one of those is acceptable as long as you've explained it in there. But one, I would have probably gone for just a punching tool for the hydraulic press to get those little vent pieces out, and then possibly a CNC cutter to get the overall shape out. Bending around a jig or a hydraulic press former or something like that for the third part, and then finishing, probably powder coating. Anodizing, I suppose, as well. Yeah, anodizing is a good example on that one. 4 points, 4 steps, 1, 2, 3, 4, and we're done. Make them very clear. Even numbering them like this, 1, 2, 3, 4, you want to make it as clear for the person marking it as possible what's going on there. They can see 4 marks there, so make it very obvious where you've identified the 4 steps of the 4 marks are. We're occasionally going to get some of these diagrams in there. So this material selection chart, they love a good material selection chart. It comes up every now and again. It shows the different material groups and how they compare in terms of density and Young's modulus. So here, a big clue is going to be what we've already got labeled on there. So we can see ceramics is on there. We can see composites. We can see rubber. We can see foams. Our 3 most obvious groups are missing. So we've got metals, plastics, and woods. It's got to be those 3. So we need to kind of look at the chart and try to figure out if there's any obvious way to identify where these are. So let's look at the bottom of our table where we've got density, lightest to heaviest. On the left-hand side, we've got obviously flexibility and stiffness, Young's modulus. We could use that. Personally, I'm looking at the bottom here. That's going to be really simple. We've got what's the lightest material and what's the heaviest material. Now, out of metal, plastic, and wood, what is the heaviest material? It is obviously on as a whole metals. Metals are the denser material. They're going to be much heavier. If I had a square centimeter block of metal and a square centimeter block of wood and a square centimeter block of plastic, and I had the 3 of them there, the metal is going to be the heaviest one. Then the lightest one is obviously going to be the wood one. It's more porous. It's going to be quite airy like a sponge. So if if I look at my pitches here, I've got my green one here, which is down my lower end, the lightest, my purpley one here, which is the heaviest one, and then this one in the middle. So it's quite obvious to me that this one's going to be our metals, this one's going to be our woods, and this one's going to be our plastics. So again, it's a 3 marker, just identifying wood. Wood or timber would be acceptable for that one, metal for the top one, plastic or polymers for the middle one. They're quite merciful with these selection charts. It's quite obvious when you think about it and break it down a step at a time. That's really how it is. Now, with materials, as I mentioned before, we've got our basic woods, metals, and plastic materials. They do like to go a little bit more advanced. There's normally always a smart material question in there somewhere. We've already done one a bit with the actual batteries, but let's go through this one. I always like this question because the picture really gives us a lot of information. So again, the pictures can really help you. This is really important. Figure 3.1 shows a pair of glasses which can be used to correct poor eyesight when reading. Now, the picture has given us loads of information. We can see there's lenses inside there. We can see there's a metal frame around it. The little nose pieces there, the little rubber nose pieces there, obviously for comfort to grip it onto the nose. And there's little rubber bits at the end where it's going to hook around the ears. So there's a number of different materials there I can consider. So smart materials are used in many products in order to enhance function or aesthetics. Identify 2 different smart materials that could be used in the pair of glasses for each smart material. Explain how it would enhance the function and or aesthetics. Now, we've already identified 4 different areas of 4 different materials there. Let's go through smart materials. Let's think about ones we were talking about before. So we were talking about, do you remember we were talking about thermochromic? Thermo means heat. The other one we spoke about earlier was photochromic. Okay, that's light. So we can talk about light reactive lenses. So we can go straight into a photochromic lens. The fact that it's, or you can call it polarized glass, you can call it smart glass. There's a number of different ways you can call it, but photochromic lenses would be enough or some form of that. And then you could talk about the fact that they react to light. Okay, now there's many different reasons why this would be beneficial. You could talk about people not having to have 2 pairs of glasses when they're reading and when they're going out in the sunshine for, as a pair of sunglasses. You could talk about safety reasons. So let's start to break this down. So obviously 1 mark here for photochromic lenses. Again, this is really important. It's a 6 marker identified too. So we're going to need to give a point here, an identification, then an explanation and link it back. So the expansion here, to shade the user's eyes when it's sunny, that gets you 2nd mark. We need something more. Therefore, making it safer when they're driving, for example. Give an explanation of why that's important. So photochromic lenses is one mark. To shade the user's eyes when it's sunny, 2 marks. Why would that be important? So they don't get in an accident when they're driving and the sun gets in their eyes, something like that. That gets you your 3rd mark. Okay, nice and simple. A number of things you could talk about. You could talk about simply as an aesthetic reason. People like sunglasses. It can look very cool when you're out and about. It's not very handy when you're having to swap between different pairs of glasses. If they can automatically change, it can be for an aesthetic reason as well as a functional reason as well. As long as you justify it, it's perfectly fine. So it's a good accessory. It looks cool, bits like that sort of thing. So photochromic lenses, shades the user's eyes, makes it safer when driving. 1, 2, 3 marks, move on. 2nd point, shape memory alloy lenses. So this is the nitinol, which is the metal frame around it. Again, we can talk about the fact that when glasses get dropped, if they're accidentally sat on or anything like that, and they get bent or misaligned out of shape, you can use heat to get them to return to their original shape, mitigating the need to have to go buy a new pair if they get damaged, if you're able to return them back to the original shape. So 1, identification for the metal. Reason being, if it got dented or out of shape or sat upon, you could then use heat to then reapply it to change it back to its original shape. 3 points, you're done. There you go. That's already 6 marks there. As I mentioned before, there's other materials there. We could talk about polymorph being used for the little nose piece to be able to hold it firmly on the nose, to be molded specifically around the user's particular shaped nose. Everyone's got different shaped noses. You talk about the bits around the ears. Everyone's got different shapes ears, to be molded and personalized for that as well, for extra comfort, for extra security. again, there's so many different things you could have given for this. So they're always really good on this. They'll always say something like identify two different smart materials when in the picture they've clearly got four different things you can talk about. They try and give you as much opportunity to talk about things. So if you're not too sure on one, you can use another one. But that's a simple little 6 marker there, and we're all good. This is a great one where we start to look at some of these smart materials as well, but we start to look at the actual function. This is where we talk about the user interfacing with the products as well. So hearing aid is a device that fits on a person's ear to make sound clearer and louder. There are different types of hearing aid. Some are programmed to be controlled remotely. Gives you a bit of information there. We've got a picture here. Again, the picture gives us nearly everything we need for the question. There's labeled an ear mold, a tube, an ear hook, a microphone, a volume control, a battery compartment. Each one of these little arrows as well is actually pointing to something that's quite visible in the picture that can give you a clue what you need to talk about. So explain how two features of the hearing aid improve ear ease of use. So let's start to look at the first bit here. Let's go round and look at some of these labels here. So one of the ones we've got up there is the ear hook. Right? Why is the ear hook invaluable? Ear hook prevents the device falling off when it's in use. Great, obvious answer. 1 mark. Why is that important? As it warps around the ear and enables the ear to carry some weight. So again, you do have obviously a circuit back there. You've got some batteries. There is a bit, it's not incredibly heavy, but enough weight for it could easily slip off the ear. So that hooking around the ear makes it so that as people are moving around doing their day-to-day life, they can walk around, run around, kind of, sit down in a chair, lean back, be able to live their day-to-day life comfortably without having to worry that it's going to fall or slip off. Especially with someone like this, people want to be able to live a normal life without having to be aware of these extra little devices on there. It just needs to be something seamless. So again, 1 mark, 1 mark, 4 marks there. We've just got one other one. Let's look at other parts here. So we've got a very clear label here for the battery compartment, pointing to a little arrow, and we can see there's a little raised edge there. Okay, so we've got battery compartment has a ridge on the surface for grip. Obviously, we want to be able to easily grip and pop open the lid on it to make it easier for the user to open it to change the batteries. If it had maybe a little socket in there for recharging for a wire, but we can see here it's a battery compartment, so it's easily to be able to pop it open and change the batteries. There's so many other things on here. We could talk about another bits. Obviously, the other obvious label up there is the ear mold. We talk about the ear mold to fit the individual's ear. Again, ears are like fingerprints. Everyone's ear is totally unique to them. So that ear mold is going to be an individual piece molded to that person. Again, for extra grip and comfort and security, so it's not falling out. So molded to fit individual ear, 1 mark, meaning the user does not need to worry about it falling out when moving around. As we mentioned before, 2nd mark. Again, that's another one you could have given. Actually, now I'm looking at it, the volume control there, you can actually see has little ridges on it as well, like little kind of gear teeth. So it's making it easier when the user is reaching around their ear, they can just actually feel with their finger where the volume control is. And it's very easy to roll it up and roll it down. That could have been another justification in there. There's even now when I'm looking at it, there's so many more answers you could have given. So it's really simple just to go through and do these basic things. We'll finish off on one this is very much geared towards the design engineering students where you do a little bit more of the kind of physics things. This won't really come up in something like a product design paper. Product design paper will just be dealing with maths. Design engineers, you're going to be doing a little bit of physics as well. So this is a great example of a calculate Young's modulus for the climbing rope. This was the belay one from before. Give your answer to 2 decimal places. Again, be very careful on that since so many people not paying attention to that. They give their answer to 3 decimal places, whatever. You're going to lose a mark. It's 5 marks there. So quite simply, 1 mark for recalling the formula. So you literally write the formula out. It's going to give you a mark. Okay. Another mark for the conversion of the radius linked to the strain. Again, if you look at your chart here, it's giving you force and strain on there. You've got it all on there. So 5 millimeters for the climbing rope. Obviously, you times it out and get into its decimal place. 1 mark there. Another mark for calculating the area. 1 mark there. 1 mark for calculating Young's modulus in pascals. So obviously you've got that point. At this point, when you're calculating things, try and get them to as many decimal places as possible. Keep them to that point. Only at the very end, take it down. So you've got Young's modulus there. 1 mark for unit conversion, and then you take it down to, at this point here, take it down to 2 decimal places. So we've got 0.424413211583. At this point, at the very end, 0.42, put it in the answer, it's done. Now you can see that obviously you've got 1 mark for each one of those points there and a mark for the correct answer at the end. Just be aware that if it's a correct answer, you're just going to get 5 marks and that's it. But always show your working, because it's always going to come down to the fact that if there is a small error somewhere, they will carry that error forward. It's still possible to get 4 out of 5 marks if you put the wrong answer in, as long as each one of these steps in your working is correct. I mean, that's pretty much the kind of things you're going to be expected to see in these papers. As we've seen in all those example questions, basics on materials, on manufacturing methods, on things like health and safety or risk assessments, on these basic kind of maths questions, and just an understanding of how all these things work. So it should be really simple enough. Just read the question very carefully, make sure you're answering exactly what it's asking you to do, and keep an eye out for things like this when it specifically says something like give your answer to 2 decimal places. I hope that's been informative and that's helped a bit, and we'll see you on the next video.